Our next presenter is not here in this room. We will be showing a video of her talk just to minimize technical difficulties, but she will connect remotely after for Q&A. So Olivia, our next presenter is named Olivia Liao. She holds a PhD in statistics from Stanford. And after a short journey in pharmaceutical industry, she joined Uber Data Science, where she has developed platforms as well as built and launched products globally. Currently, she leads data science of demand intelligence at Uber, which models, predicts how riders choose different Uber products based on different prices and experiences. Her talk is entitled Marketplace Data Science at Uber. It will discuss how data scientists use a wide variety of analytics disciplines to address diverse problems.
Hi everyone, my name is Olivia Liao. I lead the data science team within the marketplace organization at Uber. I'm currently in California, but thanks FIDA for inviting me to be on the line and share with you some of the interesting data science problems we are working on, including dynamic pricing, forecasting supply and demand, to name a few, as well as the role of data scientists and skill sets within Uber marketplace. So for those of you who are not familiar with Uber, we are currently operating in more than 600 cities in the world, including Beirut. We are in 73 countries and have done more than 4 billion rides. And our mission is to bring transportation for everyone and everywhere. So how do you get a system like Uber? And how does Uber use all this data at our fingertips and harness it to create innovations in efficiency to help improve life in cities? So as you can imagine, Uber is all about scale. So let me take you through what that looks like. Here, I'll show you our business growth in New York City area from 2012 to 2016. And each of the dots represent the starting location of an actual trip. So you can see we started from downtown Manhattan and gradually expanded to Brooklyn and New Jersey and beyond. The core of our business, which the marketplace focuses on, is connecting riders with drivers through a variety of different products, including your regular UberX, the luxury black car, and the carpool option Uber Pool. So let's start from the riders. In the rider app, we begin by asking you where you want to go, and then followed by a bunch of data-driven features. For instance, based on your historical trip data, we predict where you are most likely going to go based on where you are, and then recommend them as a shortcut so that it will just be a one click for you to get moving. We provide a route prediction based on our mapping engine in order to figure out what's the most likely travel time and distance. And we show you a variety of products so you can easily compare the time and the cost of different products in order to decide what's the right ride for you. So that means for us, we optimize on what prices we should display to the riders right now for all trips, given the current supply and anticipated demand in the near future. So everyone can get a car at a reasonable time by paying a price they think is reasonable. And obviously we want to balance that with the prices we want to commit to drivers in order to move people from point A to point B. So once you're in the app, you can slide the app up and stream your music or order food through our food delivery service, Uber Eats. So and obviously, given limited space in the mobile app, we want to use recommendation algorithm to determine the priority of the different information we provided in these swipe up cards. And ultimately, we want to sync up with the public transportation information. So if we can reasonably predict that you're going to a public transportation hub, we want to provide you all the transit information so that you can plan your entire trip. So on the driver's side, we have some of the basic pickup and drop-off flow. We help drivers track their earnings. We show them when there's a dispatch for them, how they should navigate to the final destination and so on. But beyond that, drivers' earnings is at the heart of marketplace. Since many drivers rely on Uber to pay their bills and bring food back home. So we want to help them maximize their earning given their schedule. And you can even argue, is maximizing earnings the more important or having a very stable earnings week over week more important? We cannot tell drivers exactly where they should go, but with a decent demand forecast, we can recommend drivers to go to places with the highest demand at the right time, possibly through a well-designed incentive structure so that they can get the most business. And we cannot talk about drivers without mentioning Uber Pool, which is designed to be a more effective use of cars. By sharing the car with others, riders can enjoy paying a more affordable price. So more riders opt in, then benefit drivers by less idle time. So for data scientists, we want to figure out how to best match riders with the driver. And even more challenging, how do we match multiple riders with each other and with the driver? Other than identifying riders with similar origin and destination, we may want to consider the cost of dispatch a half-filled car versus a different cost to dispatch a completed open car. And intuitively, you may think that we should just simply dispatch the closest car. But here's an example, and just one of the many edge cases where that doesn't work. So we started by dispatching this car to these riders in the red dot. And this will take riders 6 minutes to pick the rider up. But halfway through, another rider show up that is closer to the first driver. And simultaneously, a second driver happened to show up in the area and is very close to the first riders. So now it doesn't make sense for us to continue doing a cross dispatch. So we developed a dispatch algorithm that can swap these dispatches halfway through. This algorithm has reduced the total pickup time of 10 minutes across the two trips, now down to only 2 minutes in total. And we recently launched a new product called Uber Express with the idea that we don't always find riders with perfectly matched origin, destination, and travel time. So maybe by asking riders to walk a few blocks and wait for a few minutes before we send the car, we now have a longer buffer to find a better pool match for these riders. And this enables a more efficient and hence an even more affordable way of transportation. So at this point, you probably realize that Uber relies on economy of scale. The more riders and drivers, the more efficient and affordable we can offer our services. So here's an example of the evolution of our business scale in the Los Angeles area and its relationship with the average time rider have to wait from requesting to getting pickup. So as our business grew, we were able to offer faster pickup in more and more area. And when we can provide an efficient transportation, more riders are more willing to join our platforms, hence creating a virtuous circle. So the data science team in Uber Marketplace leveraged the science and all these features we have discussed above to motivate riders and drivers to make decisions that maximize the long-term efficiency of Uber markets. And addressing such diverse problems efficiently in a complex and ever-changing environment requires a wide variety of analytics disciplines, including machine learning, operation research, economics, statistics, and so on and so forth. And even so, the scale of these problems are not like anything we've learned at school. And a lot of them requires multidisciplinary solutions. I myself came from a statistics and machine learning background. But in my 3 years journey at Uber, I have added in my toolbox some optimization, some economics knowledges that I learned from my peers on the job. My appreciation of these skills have helped me build and lead a team of diverse background. So I want to use the last few minutes to touch on the different functionalities of our day-to-day jobs as data scientists. And I mentioned earlier that we appreciate expertise from various different training backgrounds, but since I'm a statistics major, here for simplicity and maybe a little bit of selfishness, I'll use statistics as an example. But you can swap off the word statistics in this slide with any other specialties that I've mentioned earlier. So data science is this sweet intersection between coding, statistics, and domain knowledge. And some of our day-to-day tasks rely on one skills more than the others. For instance, many data scientists on my team focus on utilizing their economics and statistics skills to develop innovative models, algorithms, and experiments. But as their career progresses, I always encourage them to try out the various tasks I listed here that fall in the data science bucket, so to help them build up a comprehensive view of our business. All right, I'll end my presentation here. Thank you so much for your attention, and let me know if you have any questions.